Today we will discover the formula of the area of a triangle. So we need to review quadrilaterals before we begin. The sum of their interior angles of a quadrilateral is 360 degrees. So here we have three different quadrilaterals. They all have four sides, straight, congruent, rectangle, square, and a parallelogram. So now we need to divide these in half. Okay, obviously I did not divide them too perfectly, but that's what happens when you leave your iPad at school. So now we divided them in half, and what did we get? We got two triangles. And we know that the sum of the interior angles of a triangle is 180 degrees. This concept right here is a review concept, but it's going to play into how we do the area of a triangle. They relate. So we've cut in half, and we now have two triangles. We learned that the formula for the area of a rectangle, I'm just going to draw a rectangle around it, is that area equals base times height. So that's what we worked with yesterday. Today we'll be working with the triangle. And so just like we drew a line on the quadrilateral to cut the quadrilateral in half to create two triangles, we can divide the formula of an area of a rectangle in half to find the area of a triangle. So based on your chart, on your star chart, you have area is equal to 1/2 of base times height, or area is equal to base times height over 2. Both of those mean the same thing, so those are equivalent there. And so if you notice, this is the quadrilateral formula. It is base times height, and all we're doing is dividing that in half, just like we did up here with our quadrilaterals. We divide them in half to get a triangle. So hopefully that's starting to make some type of sense of where this formula came from. So here we have the steps to find the area of a triangle. Step 1 is I need to multiply the base and the height. Step 2 is I need to divide that product by 2. And one important feature is that the base is always perpendicular to the height. And we can, just like we have symbols for parallel and angles, the perpendicular symbol is like that. Kind of an upside down T. So here we have three triangles. And so we're going to talk about the base and the height and where to find them on these triangles. On this very first one, it's super simple. If you trace that, that's 90 degrees. This is that is our height, and here is our base. So as we learned when we were doing the formula, when we're doing the formula for the quadrilateral, the base and height always make a what type of angle? Right. I just realized I couldn't see. A right angle. So the base and height always make a right angle. And so in this 90-degree triangle, that is not hard to find. However, in this middle one, it is a little bit more difficult. There's not a straight up and down line, and we know it has to be 90 degrees. So we drop a line from our tip straight down, and that forms a 90-degree angle. And this measurement right there is our height, and this measurement right here, the entire thing, is our base. So you have to be able to find your height in the triangle, which is the difficult part of the triangles, is you have to know where to drop that point down. Remember, you're always wanting to form a right angle and where to go with it. So let's look at this guy. There's no point for me to drop it down to that point, so we actually extend and we drop it here. And if I do it kind of correctly, it is here. Those are dotted lines. This is our height, and this part is our base. This does not get added onto it. Does not add on to the base length, because what it's doing is, you could do it that way, but that's traditional way. It's just saying if I go straight up from here and straight up there, kind of like we did on the coordinate plane, where would those two cross at? And so that allows us to get that place right there. So it'll make more sense as we work with it. So now we're going to switch to the back side, and we're going to do two of them together. Okay, so our first shape is a triangle. It is a scaling right triangle. It has a right angle, but none of the sides are the same length. And so the first thing we're asked to do is to find the sides, which we know is perimeter. And yesterday we talked about how in these shapes we just add them up. So we need to quickly write our measurements, and then we need to solve by adding. So here it says add the sides. So I can do some quick little math here. That'd be 40 plus 29, so it'd be 69, and the units is meters. Okay, so, oh, I'm sorry, there we go. So now we need to write our formula from our star chart for the triangle. A equals 1/2 of the base times height. So now we substitute for A. We have A, we already have 1/2, and so I'm going to have to pan back up to look at our triangle. Sorry about that. This right here is our base. It is kind of turned up on its head, but it's what it would be laying flat. And this guy is our height. So we have 15 times 25. (15 times 25). And if we do the math with that, we would get 375, and we need to divide that by 2. And so I'm going to have to come over here, and 375, and I'm going to divide it in half. So 2 will go into 15, will go in there 7 times. We get 14, that's 10. I have to add that decimal to get that 0 to drop down, and there. So our area is 187.5 meters squared, and we can pull down our 69 meters for that one here. So you need to remember with this